Welcome to the solution video for the performance evaluation challenge. Let's jump right into create our solution. We're actually going to do two different parts here. We're going to do the initial goal first, and then we'll move on to the bonus instead of doing it all at once, like we sometimes do, because I do think there is a clear line here that differentiates the two. So let's go File, New Project. And for performance especially, console is great. So .NET Framework console app. Let's call this console UI, and we'll call this performance evaluation solution. The first thing we'll do here is add our console.readline at the end to stop the system from moving on. Now, we're going to do just enough code to get this working. We're not going to create a fully rounded application, as you know, hopefully, by watching previous challenges, but I want to make sure so we want milliseconds here, and we're going to actually specify that ms afterwards, just so we know that these are milliseconds. So there's 1,000 milliseconds in 1 second, just so you're aware. You could translate this to seconds, but typically that's way too imprecise when we're talking about evaluating things for performance reasons. And we definitely don't want rounding to cause us to improperly evaluate two different items. As it is, with milliseconds, we'll get some rounding. Okay, so that's our evaluation. Now let's go ahead and create some test code to put in between. So let's start off with just simple string appending. So string test, not text, test equals empty string, and we'll do a for loop. And we'll say that we're going to do 500, 5,000, and 50,000. So we'll start with 500, and we'll say test plus equals, let's just put testing afterwards. Okay, So we're just going to append this word testing onto the end of our string. That's the plus equals. And what that'll do is it will make test longer and longer and longer. And we're going to evaluate how long it takes to do this 500 times. So at this point, we're ready to go. We don't have to do anything with this variable. We just need to make sure it does the append 500 times. So now let's run this. And it says time taken 0 milliseconds, which is quite underwhelming. So it didn't take any time at all or not much time. If we actually change this to elapsed ticks, you'll see that it did take some time. And it's not milliseconds now, so forget that, but it took almost 4,000 ticks. Okay, so there is some time being taken, but the reality is, as far as a human perspective, it's not even 1 millisecond. So let's take us back to elapsed milliseconds. And this time, let's go to our top of our range, 50,000. I'm going to try it over here. Notice the cursor is blinking here. It hasn't filled in yet. Now it has. Time taken, and this is milliseconds. 3,596 milliseconds. So almost, it's over 3.5 seconds long to do 50,000 iterations on this particular item. Okay, so that's a slow process. But notice that it was only when it was 50,000. 500, no big deal. Okay, because it didn't even register. So the other thing I notice here is if I run this again, I'm not going to get the exact same number. So 3596, if I run this again, bring it over here and wait for it. 3525, not 96. So we got a little faster. Is this process. Okay, so there's our new code. Notice we created a new stopwatch. Let's kind of break this apart. So now you got the string builder test, which is testing, doing this pretty much the same process, but it's creating a string builder. It's appending it, in this case, 50,000 times with the word testing, just like up here. And then at the end, it's putting that into a string. So you actually have it as the resultant value. Then we're going to stop. We're going to look at the time taken on this one as well. So this should be apples to apples comparison, 50,000 versus 50,000, appending testing to our string each time. So we're waiting for our first one to run. So the first one took almost 4 seconds. The second one took 0 milliseconds. Do you see how String Builder is a whole lot faster? So we've now proven that in this case, it would be more advantageous to use String Builder because it's so much faster. And just to kind of prove how much faster it is, let's add 2 zeros here. Wait for this one to get done. Notice that even with 2 zeros added on, so instead of 50,000, we have 5 million. So this is 50,000 up here, and it took 3.7 seconds. Down here, we've got 5 million taking 135 milliseconds. Let's go ahead and change that font size as well. All right, let's see how that does when we take it off. Let's take 1 0 off of a string just so we have a difference. A little better. Okay, so I filled it around a little more just to get that a little bit larger and a better color. So what we've seen here so far is using this stopwatch, we can say for certainty that String Builder is much, much more performant in this case. Now, notice when I do 5,000, let's do apples to apples, so 5,000 versus 5,000. The performance difference is 14 milliseconds to 0 milliseconds, which it's not truly 0, but it's practically 0. So, yes, that's a performance hit, but it's a performance hit of not very much. Okay, so we're talking a little bit. So that's something to be aware of as well is, okay, if you're doing less than 5,000, maybe you're doing 1,000 of these appends, no big deal to use this append method or the $sign or whatever else you want to do. Because, for example, at 1,000, the difference is 2 milliseconds. Not very much of a deal, okay? So that's something to be thinking of. I don't want you to abuse this and say, oh, well, you always use String Builder. No, you don't. You use String Builder in cases where you're going to have lots. Like as in this case right here, where if you had 5 million of them, you still want to be very performant. Okay, so that's really all we have to do the basic part of our challenge, which is a test String Builder at the different levels. Now, we didn't go through every single one of them. I had 500, 5,000, and 50,000. So there's the 5,000, which this code's not very great. But there's 50,000. I'm sorry, 5,000. And it is 16 milliseconds versus 0 milliseconds. And then we have our one where it really makes a difference, and that is our 50,000 comparison, because in this one, it's almost 4 seconds versus 0 milliseconds. Okay, so we've done a comparison, but now let's take a step back and say, this is great code. I want to use this over and over. I want to be able to just kind of pass code in and say, what's this performance versus that performance? So let's build a tool or a method to do that for us. So let's start by creating a method down here. Make it a public static void, and let's call this calculate speed. Okay, so this is our calculator to tell us how fast something ran. So we're going to pass in as first of all what we're going to test. So there'll be a method actually we're going to pass in, which is called an action. And we're going to pass into that action one variable, and that's the number of repetitions. And we'll call this action method to test. And then we'll have a number of repetitions. Now, I gave you 3 different repetitions to run against it, and I think that's pretty standard to have a set of repetitions. So let's take in a set of how many repetitions you want to do against this method, be multiple. So we can do 500, 5,000, and 50,000 repetitions and do all three essentially. So let's say int array repetitions. Let's call it, repetitions is fine. I want to call it reps because it's just shorter. The problem with abbreviations is that then it gets confusing. Is that representatives or repetitions? And so therefore, if we spell it out clearly, then it's obvious to everyone. And finally, I want to pass in the test name. So I'm going to be printing out to the console information about this test. And so I want to actually have that test name there so that I can print out, okay, this test ran with this many repetitions, ran this fast. Now in here, I'm going to need to have a loop, so a for loop. And we're going to say I equals 0, I is less than repetitions.length. So for every repetition you send me, I'm going to run the method of test with that particular repetition passed in. So we'll say stopwatch equals stopwatch dot start new. And I really don't need to, I can really just copy and paste here. So let's say stopwatch dot start. I'll put our code there in a minute. And then we're going to come down here. Let's grab this as a template. But we're going to, instead of saying time taken, let's actually just eliminate this whole thing except for the milliseconds at the end. So let's here say, let's start with test name. So a test name, and let's put it at number of repetitions, and that would be I. We'll say reps. So it's going to say our normal test 500 reps equals this long. Normal test 1,000 reps equals this long. Normal test 10,000 reps equals this long. Okay, so that's what this will do. So now what we need to do is call that method. So method to test, and we pass in, remember, one value, and that's an int. And so we're going to say, let's pass in repetitions I. That's however many repetitions are in this particular set. Okay, so that's what's going to happen. We're going to call this method, pass in the number of repetitions to run. It will run it that many times. Once it's done, we'll hit stop, and then we'll print out to the console whatever we need to. Now, if you're a little confused in this whole action thing, this is a delegate. So if you watch my video on delegates, that will help. But essentially, you're creating a delegate here so you can pass in the whole method to run the test, which is really convenient because now you can create little methods and then pass them in here over and over again. So let's get rid of or comment out actually all of this code. I'll leave it here for you so you can run the basic stuff if you want. We're going to comment out all that code. And I want to call this calculate speed to test my strings and to test something else as well. In this case, I'm going to test double versus decimal. So let's start off with a set of iterations. So we can use the same ones for all of our tests. So int array iterations equals new int array, and we'll pass right in the three values, 500, 5,000, and 50,000. Okay, so now we have an array we can use to pass in when we call calculate speed, the second value right here. So let's now create a couple of methods. Now I could do this inline, and that's very easy to do. You can say calculate speed, and then you would say, let's just say reps I'm sorry, reps, and then our arrow function, and then say our curly braces, and then put your code right in here, which that would be something like this code here. Okay, and then we pass in the number of iterations, and then this would be a append text. That's the test name we're going to call this. Okay, so we could do this. And this works. It's just a little messy because you've got this whole is instead of having this right here, I cut it out and just say append text. So I pass in the method name in my spot right here because that's what it's looking for. It's looking for a method. So now I can create another one just like this. Only this one should do what we did here, which is use our string builder. So I'll paste this in here. I'm going to uncomment it. And I need to do my repetitions here. And now I'm going to call this string. I can't call string builder. String builder test. Let's call this one test as well, so that I have some consistency and also some safety against the issues I had right here. So now I'm going to test these two different methods to see which one is faster, doing pretty much the same thing. So let's copy, paste. Oops, not that one. This is what I want. Copy, paste. This is the string builder. And make sure we call the string builder test method. Same number of iterations. And so that should be it. They both print out to the console, so we should have everything we need if we hit run. There's append text. It's done the 500 and the 5,000. And there's the 50,000. Notice that 50,000 took 4 seconds. And string builder took 0 milliseconds for all of them. So there's our comparison with a very easy tool to pass really almost any method you want into this calculate speed, as long as it follows a pattern of taking in just that one int that's the number of repetitions to run it at. Okay? So you could actually even test methods that are a little bit different. You could call one method. Let's just say you created a mail client and you were testing against, hopefully against an internal mail server or something where you're not actually sending emails out, but you have some code and you have some different code and you want to see which one's faster. You could run both of them 1,000 times or 500 times and whatever is, a typical performance, and then run both of them inside calculate speed and see which one's faster. So you create a little wrapper method called, email test client or email test 1 or email test 2, something like that. And just inside here, call one method this way and a different method the other way, and you're good to go. Okay, so we've got this little test harness now So let's go ahead and compare something else, and that is decimal versus double. Okay, so let's create a little method, public static void, and we're going to call this double test, int repetitions. And we're going to do the same basic format as this. What we're going to do, but first though, is we're going to create double x equals, let's just start with a random value, and double y equals a different random value. And now we'll say for I is less than repetitions, and we're going to say x plus equals y. So we're just taking x and adding to y. Notice that every time I do that, it's going to change the value of x, and it's going to then it's going to keep growing essentially. Okay. So that's what we're going to do. We're just going to do plus equal and just test doubles. Copy this entire function or method, sorry, and say this is the decimal test. We're going to change all these values to decimal and make sure that we put the capital M, since that constant declares that this is a decimal, not a double. And we'll test which one of these is faster, because you've heard from me over and over, use double for anything that has a decimal point, unless it's money, and then it's decimal type. Okay, so let's comment these. Actually, there's these three out. I'm going to comment. There we go. I'm going to copy this. And the reason why is because I want different values. I'm going to want different values. So now, let's say calculate speed. And we're going to say double test, iterations, and just say double's fine. And we're going to do a decimal test. And we'll say decimal. Let's run this. Check that out. Even with 50,000 iterations of that simple little addition, there's no difference in time in milliseconds. Now, there is in reality. But let's change this. Let's take out the first one. We don't need to do too many of them. But let's add 2 zeros there, so that's 500,000. And then there's 5 million. We'll run it again. And there's your difference. Double is 1 millisecond and 13 milliseconds versus 9 milliseconds and 99 milliseconds. Okay, so you see a little bit of performance difference, but we're talking about 500,000 iterations and 5 million iterations before you really see a difference. Okay, now what does this tell us? It tells us that yes, there is a difference, but it's not that big a deal. Now, don't take from this, oh, Tim just said it's not a big deal to use double versus decimal. Yes, please always use double for any number unless it's money, and then you use decimal. For any number that has a decimal point, okay? Obviously, ints are for whole numbers. So there isn't a whole lot of performance difference until you get into larger calculations or larger situations. But what this does tell us too is that every situation is different. Because if you run the same thing, you might find a bigger performance gain of using double versus decimal than I did. Or you might find less of one. Same thing for strings. It depends on your environment. And so one of the things that's very important to remember in programming is don't over-optimize early. So what that talks about is the idea that you don't try and create this super optimized program right on the gate because you might not need it. So for example, if you're appending 3 lines of text, don't create a string builder because that actually has overhead. It's minuscule, but it has overhead. And so and it's also more complicated. Just do plus equals or use the dollar sign that I usually use. Okay. So it's not until you get into high repetitions that you have an issue. And the same here for this double versus decimal. It's not until you get to high repetitions or using it a lot that you'll find the differences pop up. Okay. So that's just kind of my disclaimer. And no, this is not a be-all, end-all evaluation of performance. There are some inherent things about doing this, especially this right here, that add some performance hits to it. And so if you change the order, you might see a difference in performance. So this is a rough calculation, and you should only take this as one is better than the other when you see a marked difference, like we did with string. So we'll get into, like I said, in a training video, we'll get into how to do some more actual performance benchmarking and project evaluation, all that kind of good stuff. But for now, this right here allows you to do a really quick and dirty comparison of two different approaches to something at scale. So whether it be 1 time each or 100 times each or a set of 500, 5,000, and 50,000 times, just to kind of see the differences between two different methods. Okay? Hopefully that's been helpful. Hopefully you got something similar. And if not, hopefully you learned something in this video. Thanks for watching.